The electromagnetic spectrum shows the range of all possible wavelengths and photon energies for light. Here is a logarithmic energy axis in electron volts. Let's go from 1 microelectron volt to 1 mega electron volt. It's a logarithmic axis. The second axis is a wavelength axis with a wavelength lambda. It goes in a reverse direction. Low energies correspond to long wavelengths. For example, 1 microelectron volt is about 1 meter. 1 millielectron volt is about 1 millimeter. 1 electron volt is about 1 micrometer, and so on. At the center of the range, we have visible light. Visible light is a small spectral range of light that the human eye can detect. Energies are a few electron volts, and wavelengths are a few hundred nanometers. At higher energies, there is the UV range. It goes down to about 10 nanometers in wavelength. UV can damage your skin, but does not penetrate the body. Between about 10 nanometers and 10 picometers, we speak of X-rays. They can be either soft, if they're near the UV range, or hard, if they're at the high energy limit. Energies above 10 picometers, or about 100 electron volts, are called gamma rays. These are emitted by many radioactive nuclei. On the low energy side of the visible range, there is the infrared light, IR. It goes down to about 1 millimeter in wavelengths. The range is grouped into near IR and IR in far IR. Our eyes can't see these photons, but we can sense them as heat. At wavelengths above 1 millimeter and photon energies below about 1 millielectron volts, we speak of microwaves. And millimeter waves. They go down to about 1 meter. Your cell phone uses microwaves, and the full body scanner at security checkpoint in airports uses millimeter waves. Below about 1 microelectron volt and above 1 meter in wavelength, we speak of radio waves, which are obviously used for radio. By the way, none of the borders here are very well defined. We can also draw a frequency axis, frequency nu. It is mostly used for radiation below the visible range. 1 meter in wavelength corresponds to 300 megahertz. 1 millimeter is 300 gigahertz, and 1 micrometer is 300 terahertz. Let's zoom in on the UV and visible range. UV vis. Here is an axis for both wavelengths and energies. The wavelengths are a few hundred nanometers. We go from about 800 to 200 or 100. The corresponding energies are 1.5 EVs for 800 nanometers, 2.1 EVs for 600 nanometers, 3.1 EVs for 400 nanometers, and 6.2 EVs for 200 nanometers. There's this energy axis, and there's the wavelength axis. The human eye can detect light between about 750 nanometers and 400 nanometers. This constitutes the visible range between 750 and 400. Beyond 750 nanometers, we are in the infrared range, specifically in the near infrared range. The visible spectrum goes from red at the long wavelength end through yellow, green, and blue, all the way to violet at the 400 nanometers. The UV range below 400 nanometers down to about 315 is called UVA. Between 315 and 280 nanometers, we speak of UVB, and down to about 100 nanometers is called UVC. Below 100 nanometers, we are in the extreme UV range, or XUV.